Welcome, everyone, to today's Explainer. If you're a focused learner looking to level up your programming skills quickly and efficiently, well, you are in exactly the right place. Today, we're mastering what is arguably Python's single most important data structure, the dictionary. By the end of this Explainer, you're going to totally understand the true power of key-value pairing.
So imagine this highly relatable scenario. You've built a brilliant, lightning-fast order management system for your local masala chai shop. Everything is running perfectly until, suddenly, the entire application just crashes. Why? Because a single customer didn't leave a special request note on their order, and your code didn't know how to handle the missing information. It's a tiny, tiny oversight that causes a catastrophic failure. Well, today we fix that completely.
Okay, let's take a quick look at our roadmap for building a crash-proof system. We're going to cover why dictionaries exist, the rules of keys, managing orders with CRUD, the golden safety lesson, and advanced management. Let's dive in. Section 1. Why dictionaries exist. To really understand their value, we have to look at the primary problem they solve. Think about how frustrating it is to find a customer's sugar preference using a simple list. You might end up writing code that looks like order bracket 2 bracket equals 2. What does that 2 even represent? Without looking at your documentation, you have literally no idea. But contrast that with the absolute clarity of dictionary-named access. When you write order bracket quote sugar quote bracket equals 2, there is zero ambiguity. Dictionaries allow our data to have natural names, like a customer's email, an item's price, or an order's sugar level. Beyond just being incredibly readable, dictionaries are also blazingly fast. Under the hood, Python dictionaries use something called a hash table. This gives them an amazing property, O of 1 lookup time. In plain English, that means finding a specific order in your dictionary takes the exact same near constant amount of time whether your shop has 10 customers right now or 10,000 customers. It doesn't have to scan through every single order to find the one you want. It goes straight to it. It's like magic. Section 2. The rules of keys. These rules are surprisingly flexible. We can actually mix key types in a single dictionary. You can have an integer as a key, a string as a key, and even a tuple containing 00 as a key. Oh, and here's a really fantastic detail to note. As of Python 3.7, dictionaries actually preserve the exact order in which you insert items into them. But here is the strict rule you absolutely have to memorize. Dictionary keys must be hashable. Basically, this means they have to be immutable or unchangeable types. Integers, strings, and tuples are perfectly safe to use because they don't change once they're created. But if you try to use a mutable type like a list, another dictionary, or a set as a key, Python is going to immediately throw an error and fail. Section 3. Managing orders with CRUD. To build the core operations of our chai shop application, we rely on 4 fundamental steps, commonly known as CRUD. We need to be able to create by assigning a new key, read by accessing that key, update by reassigning an existing key to a new value, and finally, delete by removing a key entirely from the system. Applying this to our actual recipe logic, we start with create. We simply take our empty recipe dictionary and assign a string. We say recipe, bracket, quote, base, quote, bracket, equals, quote, black tea, quote. Boom, we've just created a key called base with the value black tea. To read it back, we just print that exact same key. But there's a catch. If we do a direct read on a missing key, we get a fatal key error. We are going to solve that huge problem in just a moment. Continuing our CRUD flow, updating is beautifully simple. It's the exact same syntax as creating. We just reassign the base key to green tea, and our old black tea base is completely overwritten. Now for deleting, we actually have 2 great options. We can use the del keyword to just wipe out the milk key entirely, or we can use the .pop method. .pop removes the key, but it actually returns the value to us before destroying it, which is incredibly useful. Plus, .pop lets us provide a default value, like not found, so if the base isn't there, we still don't crash. Section 4. The golden safety lesson. Let's make sure you never crash again. Listen up, because this is the absolute most critical lesson of this entire explainer. Beginners often use a dangerous anti-pattern, relying on direct square brackets to read data. If that key happens to be missing, your entire application dies immediately. We need the professional approach. Think about the exact code difference here. Direct key access without checking, where you just ask for the key in brackets, means if the key is missing, boom, fatal key error. The safe alternative is the elegant .get method. When you use .get, you provide the key, and you can provide a default value.
If the key exists, you get the value. If the key is totally missing, you just get the default value back, and the code smoothly keeps running like nothing happened. I really want to emphasize this central safety lesson so that every focused learner completely internalizes it today. Never let a missing key crash your app. Always use .get when reading data you aren't 100% certain exists. It is the absolute hallmark of professional, resilient code.
Section 5, Advanced Order Management. So how do dictionaries scale when our cha shop gets incredibly busy with complex orders? To track multiple complex structures, we use nested dictionaries. Our orders dictionary contains keys like order 1, and the value for that key is an entirely separate dictionary containing the item masala chai and a price of 120. To pull the exact price from order 1, we just chain our brackets. Also, we can use the incredibly handy .setDefault method. This looks at a key. If it's there, it leaves it alone. If it's completely missing, it automatically sets a default value for us. It's just perfect for initializing customer data. All right, let's pause for a quick interactive flashcard question to test your memory on a very common pitfall. If you write the code, if masala in my.dict, does that check the keys of the dictionary or the values? Take a second to think about it. And the answer is keys only. So the crucial point to remember is that using the in keyword strictly searches the dictionary's keys, never the values. If masala is just a value, that check will come back false. You are always searching the keys. You now understand exactly why dictionaries are vastly superior to lists for named data. You know how to build and update them using CRUD operations, you understand the necessity of hashable keys, and most importantly, you know how to completely protect your app from crashing by using .get instead of direct bracket access. With O of 1 speed and .get safety fully mastered, I leave you with this. What real-world data structure will you confidently model in your next project? Thank you for joining me for this explainer, and happy coding.